All right, in this video, we are going to go through AMC 12B 2004, number 17. The question says, for some real numbers A and B, the equation, which is given, has three distinct positive roots. So distinct meaning unique. If the sum of the base 2 logarithms of the roots, that's kind of weird, is 5. What is the value of A? The question might feel a little difficult from the beginning. It is a misconception that problem solvers, really good ones, when they look at a problem, they know exactly what to do. They see the entire solution path from beginning to end and everything in between. And you might think, well, I don't see that, therefore I can't do this kind of problem. That is not a good way of thinking about it. It might be true for some early questions that are based on historical questions from the AMC. You may, in fact, have that experience where you know exactly what to do start to finish. But if you're going to qualify for the AME, there's probably going to be 4 or 5 or more questions that you have never seen anything like it before, and you're probably not going to feel entirely comfortable. That is a normal feeling. Don't worry about it, overcome it, and just take steps in the problem and see what happens. So, what do we know? We have to ask, what did they tell us and what can we do with what they told us? So just take, distinct positive roots. Well, let's call those R1, R2, and R3. It says 3 distinct roots, so we've given them a name. Now what? Well, okay, what do we know about polynomials and their roots? Well, we might think, oh, I do know, or if you don't know, I highly recommend you learn it, Vieta's formulas. In other AMC tests and solutions, you will often see the solution writer say, by Vieta. This is what they're talking about. Vieta was a person, probably much smarter than me, and he explored a lot of these concepts. What are they? If you have a quadratic, the simplest case is if ax squared plus bx plus c equals 0. Then the sum of the roots, r1 plus r2, is equal to negative b over a, and the product of the roots is equal to c over a. Okay, these are very important formulas. If you don't know them, add them to your repertoire, your arsenal, your tool belt, so that you can use them in future questions. They come up every 2 to 3 years on the AMC, so it's a must-know concept. The negative b over a, we could think of it differently. It's the second coefficient over the first with a negative in front of it. Okay, and the product is the constant over the leading coefficient. Okay, that's great, but we don't have a quadratic. Well, don't worry. Vieta's formulas work for higher polynomials as well. If we have a cubic, the sum of the roots actually stays conceptually the same. It's the negative second coefficient over the first, which is negative 4a over 8. That's negative a over 2. We don't know what to do with that. Don't worry, we're creating pieces of information that we'll be able to use later. The other one is the product of the roots. It also works for cubic polynomials. It is not like the sum where it stayed conceptually the same as the second coefficient over the first, the negative second coefficient over the first, but it is the constant over the leading coefficient, but this time it becomes negative. So it's negative constant a over 8. For higher polynomials, these continue to work. The sum is always the negative second coefficient over the first, whereas the product will alternate between the positive constant over leading and the negative constant over the leading coefficient, so for quartic and higher. Okay, so we've got 2 new pieces of information. Where do we go from here? We don't know what to do with those things yet, so we have to go back to the problem to mine it for more information. And so we turn to the sum of the base 2 logarithms. We were probably most afraid of this part of the problem to begin with. So what we should do is just write what it says. A base 2 is log base 2. Okay, of what? Of the roots. So that would be R1. What do I do with this? It says the sum of them for all 3 roots. So it's plus log base 2 of R2 plus log base 2 of R3. And this will be equal to 5. All right. Now we have to think about logarithms. You must know the basic characteristics and formulas and manipulations that you can do to logarithmic equations. The primary one is that log base b of x plus log base b of y equals the log base b of the product of the 2 inside parts, x and y. It also works if there's 3 of them, which is what we have. So we're going to get log base 2 of the product, the product of these things. So we get R1, R2, R3 equals 5. And we just worked with the product over here. We found something about it. This must be that we're on the right path. It's like a breadcrumb, right? Telling us you're going the right way. Okay, then what do? We need to convert this to exponential. It's the only thing you can do with this. We could go back to this step, but why would we want to do that? Logarithms are exponents. So how do we convert? My method is if you have log base b of x equals y and you want to convert to the exponential form, it's something I call, and it's a little weird, I call it smiley frog face. And it's because if I start with the b, I go to the y, that's the smile part, and it's the first thing you write in the conversion. Then you're going to come over and hit the equal sign, and you write equals, and you'll come over and hit the x. And for some of you, you might see it, it looks like a smiley face of some kind, and I had a stuffed animal as a kid with big eyes like this and a smile, and it was a frog stuffed animal, hence the name smiley frog face. Incidentally, smiley frog face also works in reverse. If I want to convert this back to a logarithm, it's b log base b. The first thing you write is what you touch first. You come over and hit the x, you'll write that second. You come over and hit the equals and the y, and you're right back to log base b of x equals y. So we are going to use smiley frog face to convert 2 to the 5th, commonly known as 32, is equal to R1 times R2 times R3. Okay, and we know what this is. It's negative a over 8. Well, even if we don't know what we're doing next, just obviously solve for a, multiply by 8 to get 256 and move the negative over, and a will equal negative 256. Now what do? Let's go back. What is the value of a? We've got it. We arrived at the answer. We didn't even know that we were getting close, and we're just there all of a sudden. That is a very common thing amongst good problem solvers. You just make progress in the problem until the solution materializes. The answer then would be A. Again, the concept of this problem and the path you take to get there does not have to be known from the beginning. Just take steps. Don't worry about if you know what's going to happen or what you're going to do with the pieces that you create. Just write everything down, take steps, see how far you can get. Oftentimes, you'll arrive at the end.